Do you know how a machine is controlled and protected? I am Taha, and here we are going to discuss what actually machine monitoring system is, what steps to make these systems, why do we need those, and their solutions. So let's get started. Machine monitoring system is a kind of system if applied on a machine can protect it from wear off, failure, and to get its efficiency high. Now I would like to introduce my members. My name is Taha and I am a mechanical engineer, love to convert prototype into reality, a product designer at Upwork, a blogger and a social activist.
Hello, my name is Saab and I am a student of mechanical engineering.
Hi, my name is Farjaz Siddiqui and I am currently doing bachelor's in mechanical engineering from ND University. I have a keen interest in designing and analyzing different mechanical systems.
To understand the topic, deep learning and its application in machine health monitoring system, you need to know the following important terms. Deep learning, neural network, Internet of Things, big data. After having information about these topics, following are the steps to design machine health monitoring system. Data, converting data into signals, classification of these signals, fitting data, the predicted result. Let's understand these steps through an example. Like if we design a bridge, how would we predict its instantaneous response? Is it failing or not? How would we predict its behavior? First, we collect data in the form of images, mostly of failure due to vibration, converting these images into signals, whether it is natural or transient. Classification of the collected data into groups, for the current scenario, into failure due to vibration, failure due to flexion, bending, shearing, etc. Data fitting. Hence, you get final predicted results in the form of signals. Now discuss these topics in details. Data collection. Data can be collected in the form of images, text, live videos. It is better to make interrelations between them. Data acquisition. To use data, it is better to convert it into workable form like FFT signals, which is the acronym of Fast Fourier Transform, to simplify the model.
After learning about data acquisition, we will now look into a classifier. Now, what is a classifier? The data converted from time domain to frequency domain will help us in extracting some useful features, also known as condition indicators. These condition indicators differentiate between healthy and faulty conditions. But these features do not tell us what part of the machine needs repairing and how much time there is until failure. Now, a classifier can detect anomalies and detect different types of faults so you can gain insight into what part of the machine requires attention. Each fault will represent a class. So, in short, a classifier will help you in revealing where the actual problem lies and will help you in organizing your data into different classes. This is the most important step as the final outcome depends on this and can change with respect to the data collected and organized because of classifier. After classifier, the next step is data fitting. It involves training of a deep learning model and then testing if it's working accurately or not. The data in workable form is separated into training data and testing data, typically in the ratio of 7:3. We prepare the network architecture, that is define its layers and specify training options. The testing data checks how well the model or network performs. This model that we have trained and tested will now relate the extracted features and the degradation of the machine. We can plot a remaining estimated life plot, which will help us in scheduling timely maintenance of the machine. If the results that you have predicted and found out are not satisfactory, then this simply means that you need to increase your data set and apply these steps all over again. Why are we collecting so much data and organizing it and using it to train a deep learning model? Why do we need a machine monitoring system? Because mechanical failure can happen at any time. Let us consider an example of a gear mechanism. We know that when two gears mesh together, wear and tear occurs. But we found out how much time is left before they eventually fail, and we need replacement. We will follow the following deep learning based machine health monitoring steps. Firstly, enough data needs to be collected from the machine to train the neural network. This data may consist of healthy and faulty operations. Next, this data needs to be in proper form, that is, it needs to be well organized, and to do this, we need to convert it into workable form. For example, in supervised learning, we separate the training data and testing data typically in the ratio of 7:3. We remove the features that have a constant value, then we normalize the training predictors. Then we prepare the network architecture, that is, defining the hidden layers, fully connected layers, and specifying the training options. Now we train the network. After this, the network is tested by the testing data and check how well the network performs. For example, in MATLAB, this can be checked by the confusion matrix. If the network is not accurate, we define a cost function and run the testing data again. After this, we can use the network to get the outcome in the form of plots in order to predict the maintenance schedule and the failure time. The neural network that you use depends on the type of problem that is occurring in the machine and the type of data you need to train.
I am here to discuss more about deep learning in machine health monitoring systems. The field of deep learning is itself based on collection of data. For example, in machine health monitoring system, if we want to apply deep learning techniques, we need to collect relevant data. And for that reason, we need sensors. Sensors play a crucial role in collecting precise data. For example, in machines, we have sensors for humidity, temperature, oil level, etc. These sensors collect information, and that information is used in computer software to provide meaningful value. A sensor provides continuous monitoring, reduces downtime, improves performance, and provides a huge amount of data that can be used to design and operate a machine health monitoring system. Computer vision is a field of artificial intelligence that trains computers to interpret and understand the visual world. Using digital images from cameras, videos, and deep learning models, machine can accurately identify and classify objects and then react to what they see. Today, a number of factors have contributed towards the growth of computer vision. Some of them are mobile technology with built-in cameras that have saturated the world with photos and videos. Computing power has become easily affordable and easily available. Hardware design for computer vision and analysis are more widely available. New algorithms like neural network can take advantage of the hardware and software capabilities. Computer vision works in three basic steps. First is acquiring an image. The second is processing the image. Deep learning models automate much of this process, but the models are often trained by first being fed thousands of labeled or pre-identified images. The third step is to understand the image. Today's AI system can go a step further and take actions based on the understanding of image. There are many types of computer vision that can be used in different ways. Image segmentation, object detection, facial recognition, edge detection, pattern detection, image classification, feature meshing. Simple application of computer vision may only use one of these techniques, but more advanced uses like computer vision for self-driving cars by using deep learning methods in machine health monitoring system rather than conventional method, we can be more precise with our maintenance schedule.